Hello, algebra. So I wanted to go through quickly and just kind of tell you about the rules overall. So this is kind of just a summary of everything we've learned about exponent rules that you should feel very comfortable with right now. So our zero exponent rule was the most recent one that we learned, and that is that anything to the zero power is just one, right? Anything to the zero. Could be x, could be y, could be 152. Doesn't matter, it's one if it's raised to the zero power. Our negative rule means that we need to move our base to the denominator and the exponent turns positive, right? We move our base to the denominator and our exponent turns positive. So we can see these in a few of our examples over here. So 5 divided by 5, which is really 1 minus 1, right? So 5 to the 0 is really 1. Negative 567 is really 1. W to the 0 is really 1. 2 to the negative 1 is really 1 over 2 to the 1, or 1/2. And then df to the negative 2 is really 1 over d times f squared. And then negative 127 to the negative 3 is really 1 over 127 raised to the third power. Product of powers rule is next. Product of powers rule. So this is where we have the same base. We can add our exponents. We get a to the m plus n. So that would be x to the fifth, right? Because we do 2 plus 3, x to the fifth. That would be 3 to the negative fourth plus 6. So that would be 3 squared. And then we would have 5 to the negative 2 plus negative 1. So that would be 5 to the negative 3. Power of a power property says that we do multiplication on our exponents, so m times n. So 2 squared raised to the third power would be 2 times 3. So that would be 2 to the sixth. X squared raised to the third power would be x2 times 3. So that would be x to the sixth. And then m to the fifth power raised to the third power would be, that'd be quintic, by the way, in case you care. That'd be m to the 15th power. All right, our power of a product rule says that we basically just distribute that, right? So it becomes ab to the m power is a to the m, b to the m. So we just distribute that, basically. So 3y squared would become 3 to the fourth, y to the 2 times 4, because we're just distributing that. So that's really 3 to the fourth, y to the 8th. For this one, we've got 2 times 5 raised to the third power. So that become 2 cubed times 5 cubed. And then down here, x, y, z, all raised to the fifth power would be x to the fifth, y to the fifth, z to the fifth. Our quotient of powers down here. Quotient of powers is when we need to subtract bases that, like bases, we subtract their exponents, So this would be a to the m minus n. So we've got 5 to the sixth power divided by 5 squared. So this would become 5 to the sixth minus 2, which is really 5 to the fourth. For this one right here, we've got x to the fourth times y to the third divided by x squared, y squared. So this become x to the 4 minus 2, y to the 3 minus 2. So that's really x squared and just y to the 1, technically. And then power of a quotient property. So this is where that m applies to both the numerator and the denominator, right? That exponent applies to both the numerator and denominator. So this becomes a to the m over b to the m. So when we do this, we end up with, I'm going to take my negative here and just stick it with the numerator. So negative 2 cubed, 3 cubed. And then for this one down here, we would have x to the fifth, y to the fifth. So a little bit of review of all of our rules, and now we're going to actually try applying all of them. Okay, we're going to try applying all of them. So our first ones up here are just simple product reminders. And then I actually want to go through and do some of these. All right, I want to go through and do some of these. So I'm going to start with 27 and 30. So with this one, oh, sorry guys. Just my morning alarm. So with this one down here, I'm going to rewrite this so that our A's are all together and our B's are all together. So we've got an A times A to the 5th. Ooh, I forgot to move that 6. 6 goes out front. Times negative A. And then we've got a B times B times B. So now that I have all the A's together and B's together, I can take my negative 2 and put it out front with my 6. So that's A to the 1 and 5 and then another 1. So 1 plus 5 plus 1. And then we've got B to the 1 plus 1 plus 1. So that'd be negative 6A to the 7th, and then B cubed. All right, we're going to do this one next. So I take my coefficients and put them out front. So that'd be 8 times 10. C comes next, so C squared, C cubed, and then times D to the 5th. Remember, if it's just by itself, it always, always, always has an exponent, right? Everything has an exponent. We just don't always see it. So in this case, for example, the 8 has an exponent of 1, the 10 has an exponent of 1, but I don't need to care about them. So we've got 8 times 10 gets me 80. And then we've got times C to the 2 times C to the 3 would be 2 plus 3 is 5. And then D to the 1 times D to the 5th is D to the 6th. All right, I am going to turn the page so we can try some more. All right, we need to simplify these. So we've got 3x to the 5th, and it's being raised to the 2nd power, divided by 27 x cubed. So first things first, I'm going to do my power of a power rule. So we've got power of a product rule. So we've got 3 squared times x to the 5th to the 2nd power over 27x cubed. So I can simplify that a little bit more. 3 squared is really 9. And then x to the 5 times 2 is really x to the 10 over 27x cubed. Is that simplified? No, it's not. We should be able to simplify these. They both have 3's that go into them. And we should be able to simplify our x as well. So 9 goes into 27 3 times. That means I can reduce this down. So I have a 1 in my numerator and a 3 in my denominator. And then I've got x to the 10 over x cubed. When we have a quotient like this, a fraction, we need to subtract our exponents, right? So this becomes 10 minus 3. So we end up with a 10 to the, x to the 7th in our numerator divided by a 3 in our denominator. So that is our final answer. Technically the 1's still there, but you know, he's a 1, he's a ninja. You don't have to write him. All right, let's do this one next. So we have a power of a product. So I need to just distribute that, so to speak. So we get 2 cubed times a squared to the 3rd power times b to the 4th to the 3rd power. And we've got 4a cubed cubed. So this is really, 2 cubed is really 8. A to the 2 raised to the 3rd power is really a to the 6th. And then we have a b to the 12th over 4a cubed b cubed. So now I need to actually subtract my exponents, and I can reduce this down as well. So my coefficients can reduce down to just a 2. And then a to the 6th over a cubed is really a. 6 minus 3 is 3. And then b to the 12th divided by b cubed is really b to the 9, right? 12 minus 3 is 9. So that's my final answer. All right, so try a few more on this page. I am going to move on to the next one. All right, anything to the 0 is 1. Anything to the 0 is 1. Now this is where it gets trickier. Anything to the 0 is 1, but what is that 0 touching is the question. The 0 is only touching the y. So this is really 5 times 1, which is actually just 5. All right, it's a little tricky there. All right, so for this one, again, we've got a 0 in our exponent, but what is the 0 touching? It's only touching the a. So that means we really have negative 8 times 1, which is just negative 8. So a plus b to the 0. Hey, the 0 is touching everything, so that's just 1. A to the 0 plus b to the 0. Well, what is a to the 0? 1 plus b to the 0, 1. So that's actually 2. Haha, tricky. What is the exponent for the 3? It's got a 1. What's the exponent for the y? It's got a 1. So only the x has an exponent of 0. So this is really 3 times 1 times y. So that's really just 3y. What is the 0 touching? Just the mn. So the 10 stays there, and then this whole thing turns to 1. 10 times 1 is 10. All right, so there are lots more on this page. Please try them out. All right, get a good feel for these 0 power properties. Some of them are a little trickier too. So the answer key, I believe, is already posted. We've done tons of those already. So the next one I want to do is up here. I want to do some of these up here. So let's start with this one. This is really a negative 1 is in there, right? This is really a negative 1 that's being raised to the 3rd power. And then q to the 7th power being raised to the 3rd power. And then r squared being raised to the 3rd power. So negative 1 cubed, that's really negative 1 times negative 1 times negative 1. So that gets us just negative 1. And then q to the 7th raised to the 3rd is, we know we have to multiply those when we do a power of a power. So this becomes q to the 21. And then r power of a power rule again, r to the 6th. So this is negative q21 r6. All right, I'm going to come down here and let's take a look at this one right here. So we've got power of product rule first for this guy, right? We need to get rid of our parentheses using PEMDAS before we can do anything else. So that becomes 2 to the 3rd power, and then a squared to the 3rd power, plus, for this one right here, we've got 3 times a to the 4th, right? It's just a product of powers. That's it. Or, yeah, product of powers. There we go. Then for this one, 2 cubed, that's really 2 times 2. Times 2 is 8. And then a squared raised to the 3rd power is really a. We know we multiply those, so that's 6th. Plus, we've got a power of a product here rule. So we add our exponent. So we've got 3a to the 6th. That is all we can do because of this plus sign. We can only use our product rules when we're multiplying. If we add, we just add. So because we are adding here, this is really, we have the same exponents, right? A to the 6th, a to the 6th, those are the same. We've got 8 of these and 3 of these. Well, if we have 8 and 3 and they're all apples or all oranges or all bananas, however you think about it, if they're all the same, which they are, they're both a to the 6th, then we just add these. So this becomes 11 a to the 6th. All right. So I want to remind you that you know about that already, combining like terms. All we had to do here was combine like terms. This one is very similar in that regard as well. All right, email me if you have questions. I am happy to help.